Hey guys, another day. Let's see what we have. Okay, Leetcode. What are these? Let me close those. And let me start a timer. Timer for. Okay, let me start a timer for 45 minutes. And then if we don't get to a solution within that time, we'll try to look for some help. Or at least try to see what else. Sorry, what I meant was after 45 minutes, we'll see how to solve this. We'll try to explore some options. Okay, let's start. Let me put the timers up there. Like that's timer. Is it possible if I minimize it? Okay, let me close that. Minimize. How do I? 1 second. Okay, that's the. Okay, let me just minimize it. Doesn't matter. Okay, maximum amount of money a robot can earn. You're given a grid. A robot starts at the top left corner of the grid. It wants to reach the bottom corner. Okay. The robot can move either way, either right or down at any point in time. So, Excali draw. Let me remove all this. 1 second. Cancel that. I don't need to remove anything on me. Okay. So we have a grid, right? Okay, I have a. Let me create a grid. Okay, let's. We have a grid, and our robot starts at 0. Our robot is here. So our robot is right here. It can only move left and down. Where is it? So a robot wants to reach, either move. It can either move on the right, so it can either go right or down. Okay. Okay. The grid contains the value in each cell. If it's greater than the robot gains that many coins. If it's less than 0, the robot encounters the robber and steals the absolute value of coins. So what does it mean? So let's say robot encounters another one, and then, well, we have to deduct it, but what if it absolute value of the robot steals absolute value of coins I and j. Robot has a special ability to neutralize robot in at most 2 cells on its path, preventing them from stealing coins in those cells. Okay, so this ability is better for the 2 maximum, right, to where the value is max. Robot's total coins can be negative. Okay, return the maximum profit a robot can gain on the route. Okay, so let's see what we're given. Let's consider one route. In each route, let me do the docstring method. 1 second. Create some strings. Okay, so each route, what do we have to find out? So we go right and bottom. Okay, and also robot can either move. Grid contains the value ij in each cell. So why don't we do how many? What's the constraint like? Constraint is 500. So it's not that much, honestly. We could create a list. What I'm thinking is, okay, create a list of each route. That's like, I don't know, that's the optimal way. So creating a list of each route is, we have n routes, so O of n, and then for each route, what are we to do? Each possible route, right? The robot starts at the top left corner of the grid and wants to reach the bottom corner. The robot can move right and down at any point in time. Steals absolute value. So let's say if there was a negative with the robber. Okay, so they will take that many. So anyhow, the max absolute. Okay, for each route, if so, robber is like any negative value, and we have the power to neutralize. So what that means is we need to find the top 2 max absolutes, and so why don't we do this? For each list, we have a list of robbers, and then we sum and we remove, that is we have a 2 absolute, we need to find 2 max absolute of robbers and block them. So how to do that? So when we are creating, so how to do it? What I'm thinking is, let's assume we are for each value, when we encounter a negative value, we will put that in a robber array, right? And then, but should we keep a running sum, or should we? Is it possible to do it with a running sum? Robber can move either right or down at any point in time. Okay. How do we do this? How do we do this? A robber can move. To neutralize robber at most 2 cells on its path, preventing them from stealing. Let me see some examples. We start at 0, then we move to the right, gaining 1 coin. Total coin is 1. Move. Here the robber is robber. Robber uses 1 and avoids the robber. Okay. 1, 2, gaining 3 coins. And move to 2, 2. What topics are you using? Array. What's the staff topic? I don't know what staff is. So let's sync. So first we start at 0, 0, right? Now at this point we have the option to go right or down. If we go right, we compared the option, but that won't matter because we actually have to check all the possible paths. No, we can't just skip a path because we don't know what lies beneath it. So while if we go right and then down, we create a list. Or what if we create a new matrix, right? And then at each cell, so we do this. So we started here, robot is here. If whatever value, we plus that value to the robot here and here as well. What if there's a robber here? We minus that value. But there's a concept of that blocking, right? But let's say blocking doesn't exist for now. We keep tracing the max plus value. Let's do this. So when we're traversing, let's say if we find a robber, let's check. We set that max value to the robber. Okay. Because we can always add it back, right? At the end of the list, if you're blocking it, we can always add it back. So we keep track of the max 2 robbers, right? Okay, so what I'm thinking is, we will do so what we will do, so we go from R to whatever exists here plus R. Okay, but okay, and let's say there's a negative value here. Okay, and then we still do it. We create a value here. We can also go down here. What if there's a negative here? We have some value here, and we create a max 1 for robber and max 2 for robber. Or should we create a matrix? What can we think here? Here's my kind of thing. Given is the top left corner, you have to reach at the bottom, right? The robot can move either right or down. So let's first do integer m equals to number of columns, because that is equals to coins dot length, and integer n equals to the coins bracket 0 dot range length. It contains a value but no latency, such that okay, so do we create a new for each loop, should I create a new matrix or should I just keep one matrix? But the matrix can change. Because here's the thing, right? What if we have a value that's 1000 here, rest is all like 2, 3, 3, something. We don't want to miss this path. If we take, let's say, there's 1 here, there's 20 here, so we go right first. If, let's say, I were to do where my robot takes the most optimal path, like whichever value is higher, robot goes there, and it compares 2 and 3, it goes to 3, and now it doesn't have anything to compare here, so it'll go down, again, down, and then that's a max answer. But that is not correct because we actually mixed the max value. So we can't actually compare the rows, adjacent rows of our column to opt for an optimized path. We actually have to take every path in consideration, I think. Let me just type in what I'm thinking. We need to take all the possible paths in consideration, right? What I'm thinking, maybe we create a dummy matrix, and what do we do in dummy matrix? For a matrix, how do we think about this? We need to create a dummy matrix. We create a dummy matrix, and robot can move. And the thing is, while we are choosing a path, if we update the value for the next path, we need to reset it and save that. Next value. Okay, let me create a matrix and reset it, create path, but store the max coin count at the end in an array, and also keep in mind of the block ability. So we add back the 2 max block values, and so let me have an array, integer array max, or maybe have a list, because we don't know the size, right? Shouldn't I have a list? Okay, I have an integer array answers equals to new array list. Okay, and so we created and then for each, so while our indexes are not at the end, so how do we traverse only left and right in an array? Let's think about that. How to traverse only left or right? Sorry, right or down? Right or down? How do we achieve this part? Okay, let's think. How to achieve the walking stage of right or down? So for each path 0, 0, it's a set. So 0, 0 we could only go. So if we were 0, 0 here, so we can for each row 0, 1, and then we can go 1, 1, but we can't go 0. How do we traverse? I've worked on a similar problem, but I remember I used a little bit of AI's help. But okay, this says think what can I do? What can I do to traverse? Should we create? How do I create? If we go 0, 0, so first thing we could is go through the first for each row, right? Or we go column Oh, robot has a special. Let me see if there's a hint. Yeah, I don't know much about that dynamic maximum value robot can out starting as a light hand, having neutralized key robbers. Yeah, it's right top to left. Excel. So if we have, I don't know much. I haven't learned dynamic programming, so okay. Feel like this robot has grid contains. So if we have, this grid contains value coins ij and cell. Robot has gained. How do we traverse from here to here? Or so if each cell has, how do we loop only right and down? Do we keep a track? When we are at the last cell of a row, we can't go to the first column, or do we do a while loop? Yeah, I don't know how to. Okay, let's learn. How can we move from here to here? What do we do? Each cell. So if we start here, 0, 0, 0, the next step obviously would be each column I go 0, 1, or we go down, that is 1, 0. These are two different paths, right? Okay. Yeah, I think I need some help. I don't think I'll be able to. This is annoying, but I don't know what to. I have to learn dynamic programming. So let's try to work with ChatGPT. I think I don't and learn. I'm not gonna directly ask the answer, but we will. I'll give it my thinking and then see how it works. Okay, so we have this. Control C. Okay, Control V. Oh, sorry. I'm using an attached keyboard to a Mac, so it's a little different. Windows V, Windows C. Okay, I do not want you to tell me this solution in one go, but work with me in clearing my concepts as I mentioned in the comments. What's the first? Yeah, that's what I was thinking. Number of paths. Single path plus instead of each cell, what is the best I can do reaching here? Now let's refine your thinking. You said robot can utilize top. This is not globally optimal. Why? Because the best two robbers utilize depends on the path. Yeah, so we cannot collect globally and pick top two. That I didn't mean that anyway, but when you're standing at a cell ij, what affects your state? You already know the position coins collected so far. Now, how many utilization? How many? Try to think and answer. If I define a state where I could include something like this, what should this? What should this? What should replace this int? Most due neighbor. So that will define. Reply with the idea of. You see, I have little to no experience in TinyP, but I still don't want you to give me answer right away, but I wanna learn. I am thinking the new DP I J and K equal to maybe cell value, but K represents the two block ability. but the meaning of DP is fixed. DP should not just store the cell value, so DP should answer what is the maximum points I can have when I reach ij. Use correct implementation, max points collected, and using k neutralizations. Profit. Now think about transitions. When you are at ij, you came from I minus 1j top and left. Now, if point ij is a negative, what are your choices? Option A, don't neutralize if you still can. Try what happens. See, what I am missing is, since we don't know what lies ahead in the path, what if after using both the blocks we encounter a massive property? What this means in practice is any cell ij, we don't just store one value. Best if used. Oh, okay. So at each cell we are storing 3 values. It uses both neutralizations. Allow. Okay, so for each cell we are storing 3 states. We store 3 states. Those 2 times. What each state represents. So okay, now let's move forward. Now you have the full one. Let's say dpij equals to minus, you're at ij, coming from a previous state with k equals to 1. Fill this in. New coins equals to previous plus minus 5, and k becomes 2. Yeah, that's what I mean. Okay, remains. Okay. Okay, final. What if k is 2.ij? No, we can't neutralize. We can't. At each cell ij, for each k you come from top left based on positive. At each cell ij, for each k you compare from top left based on coins ij. If positive, we add. If negative, choose. Okay. Try this. So dp I. So how do we initialize a dp with 3 ijk values? Do we start 3 loops or loop row and column maybe? No, you don't need a separate loop over k. You mainly loop over rows I and j, and inside that you handle. Okay, so okay. Do shift F. Okay. So let's create dynamic programming. I'm not gonna look at this. I, j, and k, which is equals to. Is it new dp or int array dp? Right, that's what I was thinking. Let me have an int array dp equals to new int array of row, column, and 3, right? Can't leave it. Coins can be negative. 0 might look like a valid answer. So initialize with something like. What do you mean? Have 3 values of k. Okay, so it could be 0, 1, and 2. Initialization very important. You can't leave it as 0 because coins can. So you might initialize with something like. Okay, let's loop over. For integer equals to 0, m must be less than m minus number of rows minus 1. Oh, sorry, integer. Let me give it I equals to 0. I must be less than for integer I equals to 0. I must be less than m. If m and I plus plus. What do we have to do? Robot scan. So that's m if number of rows are 4. The last row and column would be 3 comma 3, right? If m is 4 plus then for integer j equals to 0. We start at 0 0. J must be less than I plus something, I think. J must be less than n and j plus plus. Okay, so these are the two basic loops. So base case. So we initialize with something like, so we have a new matrix with, okay, for teacher k equals to 0, k must be less than 3, k plus plus, dp array of I, j, k equals to integer dot min value, integer dot min value. Okay, so I want to see. So we just created a dp array with all cells minimum value. Do we call dp this an array matrix? Oh, sorry, not an assignment. Yes, equals to integer. Fix this. Yes, array and 3D arrays are best. 3D dp array. Earlier I asked you add 0 0 with. So if the first value is a robber with k equals to 0, coins equal to -5 and k equals to 1, we coins equal to 0. About at the start you can only, you can't use 2. So 2 is initialized based on what? Yes, next step. Let's move to the transition. When you're at I and j, you can move from coin from previous state. How would you compute? So let's say if coin ij. So try to get the formula, words or code from I minus 1. So dp I j and k will be equals to dp of I minus 1. Let's say j k plus this, or we do j minus 1. So because dp is not accumulative, we are choosing the best path, not summoning path. So correct thinking, you come from ij, come from top I minus 1 jk, those not sum. So for a positive cell, so equals to max of, so you are choosing the best previous path. What if that means state was never reachable? So if coin ij, how would you compute? state was never. You must be careful not to use invalid states. If at an if, I have taken a loss. So for a positive cells, DPI, take a max of this. Okay, timer is up. If you're choosing the best previous path, then adding the current coins. One more important, what if we get integer dot, and that means the state was never reachable, so you must be careful not to use these invalid. So now you trust. Let's level up. If is a robber, if we encounter a robber, we choose the max of encounter a robber, so we choose the max that positions, so max when k equals to 0 or k equals to 1 or k equals to 2. No, you don't choose from it. Instead if k is already fixed. So what happens at a robber cell? We compute for each case. Case 1, you have not used the ability here, only option left. Case 2, you have robber 4. So at a robber cell for k equals to 1, where we've already encountered one robber, we can either come from state for k equals to 1, we minus the coins, and k equals to 0, we neutralize. What is neutralization? Oh, okay. At reach k. What is the best way to reach exactly k used for dpij and 0 new neutralization, and also we cannot neutralize, so dpij x of top and left minus 5. So I won't use neutralization here. It's not a choice. The positive you don't even care about. No. Now you have a full rule set for a positive cell. Always take it. Case is the same for a negative cell. Don't neutralize. Negative cell, we have an option. We don't neutralize. Take the lowest. What do I choose? Okay. For each maximum coins, you're gonna have reaching cell I and j using k. What are our moves? To reach ij from top left, change if we neutralize. Step 3, build vessel to be defined. Case 1, value is no robber decision. The no decisions remaining, we just add it, right? If value is less than 0, robber option A. 0 or k is less than 2 remaining. What if that'll ask at the end dp. max of, don't neutralize. Start at 0 0. Okay. So integer infinity equals to integer dot min value divided by 2. Okay, so we have this. So the first case is if coins, the coin or coins bracket 0. If the first thing is greater than 0, then dp of then for loop for integer k equals to 0, k must be less than 3, k plus plus. We do dp of 0 bracket 0 bracket k equals to coins value bracket 0 and 0. No, right? This is what would happen dp. Else that means we found a robber. Is base case is a robber. Else else what we do, 0 0, we didn't neutralize equals to coins bracket 0 and 0. If we did neutralize, that means we used 1k 1 equals to 0, and that is not possible, but we'll just write it 2 equals to 0. Okay. So teacher, how do we fill the dp? So we go so this is how we do for teacher I equals to 0, I must be less than m, right, and I plus plus. Same for integer j equals to 0, j must be less than n, j plus plus. If I equal to 0 and j equal to 0, we continue. So we don't take the base case. And then teacher, for each loop, if I is greater than 0, if j is greater than 0, j is 1, then dp is 0 1. So once we do continue here, we start another loop. For teacher k equals to 0, k must be less than 3, k plus plus, right? And then we have a base value, integer value is equal to coins bracket I, and initially it's coin integer value equals to coin. We will probably update it at the end, right? If we go right, if k is greater than 0, dp of I j k equals to math dot max of is equals to math of max of dp of I j k and dp of I is greater than 0, I minus 1 bracket j and k, right? If I is greater than 0, math.max of dp I j k plus value of see, we are adding plus val inside the max method. Max of, if I come to the tower, take the best path of next step at I j currently at dp of j. Plus ijk math of this plus the value, okay? Math of ijk and value, ijk I minus 1 j and k plus value, okay? So what's happening here is if I is greater than 0, so if we are coming from the column side, if column is greater than 0, we can go from again dp of I j k equals to again math dot max, okay, what should be max here, dp of I j k comma dp of, we go into the previous column cell, k, we add the value, if proper, if value is less than 0 and k is greater than 0, that means if proper, and we can neutralize if I is greater than 0, k is equal to less than 0, k is less than, if again we do the same thing to see, we ijk equals to k comma this and k minus 1, we don't add the value now because if I is 0, and if this, if I is greater than 0, then this, okay. If j is greater than 0, let's see, if j is greater than 0, this k minus 1, don't need the value again, right? And what are we returning? 1 2 3 4 1 2. Returning math dot max of what? dp of m minus 1 bracket of m minus 1 bracket 0 bracket dp of m minus 1 n minus 1 bracket 1 comma dp of m minus 1 n minus 1 bracket 2. This cell 21. At every cell come from the top left. What is wrong? If okay, so what we have, if coins length row column integer dot min value divided by 2, that's correct. Integer array, that's correct. For I equals to 0, I must be less than m, I plus plus. For j equals to 0, j must be less than m, j plus plus. Base case is just the base case. Base case is if dp bracket 0 0 bracket 0 equals to coins bracket 0 0, okay, and then dynamic programming of 0 0 1 equals to 0 and dynamic programming of 0 0 2 is equal to 0. J equals to j must be, if I and j are same, continue. K equals k must be less than 3 and teacher value equals to coins ij. If I is equal to than 0 and dp of I minus 1 bracket j bracket k is not equals to teacher dot is not equal to inf is not equal to inf. If j is greater than 0, C, and if I do the same thing, I bracket j minus 1 and of k is not equals to ij k and j, we go one column behind. Okay, if if k is greater than 0, check if I is greater than 0 and dp to c b to c. If k is greater than 0, check if I minus 1 and j and k is not equals to I is greater than 0 and dp of I minus 1 j and k minus 1. infinite and math.max of dp of ij k comma dp of ij minus 1 k minus 1. Okay. Return math.max of dp of m minus 1 n minus 1 0 comma math.max of dp of symbols caps lock A. Okay, bro. This problem, well, I didn't know dynamic programming at all, so this was hard for me. Well, I'll keep learning. Someday we'll get it without using AI.